Imposing masses of mystery drift silently through the vastness of space, defying the limits of our understanding. For generations, black holes have remained one of the most puzzling and fascinating subjects in astrophysics. Enigmas that absorb everything, even light, and leave behind nothing but questions. But now, the time has come for a radical shift. Thanks to the James Webb Space Telescope, we're finally getting a clearer view of what lies within these titanic phenomena. What once was speculation is now entering the realm of discovery. Join our channel as we venture to the farthest edges of our known universe to explore the heart of a black hole, an object so extreme that it bends not just matter, but space and time itself. If you're fascinated by the mysteries of the cosmos and want to stay informed on space exploration, discoveries, and scientific breakthroughs, make sure to like this video, subscribe to our channel, and turn on the notification bell. The story of black holes begins in 1916, when Albert Einstein's general theory of relativity predicted their existence. Although the term black hole wasn't coined until the 1960s, the mathematics behind Einstein's theory strongly implied the existence of regions in space where gravity was so strong that nothing, not even light, could escape. At first, the idea seemed too bizarre for many scientists to accept. But that skepticism faded when observational evidence started piling up. In the late 1960s, astronomers studying the Cygnus X1 system made a groundbreaking discovery. A luminous blue star was emitting powerful X-rays. What caught their attention was the behavior of this star. It appeared to be orbiting an invisible companion. The X-rays it emitted weren't random, they were being pulled by an unseen, extremely massive object. This marked one of the first solid pieces of evidence for the existence of black holes. Since then, what began as a strange anomaly has grown into a massive field of study. Scientists now estimate that there could be as many as 100 million black holes in our Milky Way galaxy alone. Due to the difficulty of detecting them, since they emit no light, the true number remains uncertain. But what is clear is that black holes are far more common and significant than once thought. So, what exactly is a black hole? According to physicists, a black hole is a region in space where matter is compressed to an extreme density, forming what is known as a singularity. This singularity lies at the core, surrounded by the event horizon, a boundary beyond which nothing can return. Once something crosses this horizon, escape is impossible unless it can travel faster than the speed of light, which, as far as we know, is not possible. To describe what happens to objects falling into a black hole, scientists often use a terrifying metaphor known as spaghettification. As an object approaches the singularity, it is stretched vertically and compressed horizontally by immense gravitational forces. If a human were to fall into a black hole, they would be pulled into a long, thin strand, slowly torn apart by the intense tidal forces. It's a gruesome fate that emphasizes just how extreme and alien these regions of space are. Thankfully, the closest known black hole to Earth is about 1,500 light-years away. While that might sound relatively close in galactic terms, it's still far enough that Earth is safe from any immediate threat. Yet, understanding these cosmic beasts remains a top priority for scientists. In 2021, the scientific community made another huge leap forward when they published the first detailed image of the black hole M87. Captured by the Event Horizon Telescope, a global network of radio observatories, this image revealed that a black hole is not merely an invisible vacuum in space, but a layered and dynamic structure. M87's black hole showed three distinct layers: the accretion disk, the photon sphere, and the event horizon. Let's break that down. The outermost region is the event horizon, the point of no return. Anything that crosses this boundary is pulled inexorably inward. Beyond the event horizon is the photon sphere, a region where gravity is strong enough to force light itself into circular orbits. And deep within lies the singularity, the central core where all the mass is concentrated, and the laws of physics as we know them break down entirely. What makes black holes even more enigmatic is that each one is unique. Their mass, spin, and charge can differ vastly. Even if we manage to fully understand one black hole, exploring another may mean starting from scratch. That's part of what makes studying them so difficult and so thrilling. We can't observe a black hole directly. We can only infer its presence by studying how nearby matter behaves and what kind of radiation is emitted as material falls into the gravitational well. We also can't send spacecraft into a black hole. Anything that passes the event horizon is doomed to be crushed. This means all our observations must be made from a distance, usually by examining X-rays, gamma rays, and gravitational waves. And while probes like Voyager have ventured into interstellar space, even they would be powerless against the immense pull of a black hole's core. Despite these limitations, scientists have proposed numerous theories about what might exist inside a black hole beyond the singularity. One of the most intriguing ideas is that black holes could be portals, gateways to other galaxies or even other universes. In this view, a black hole could be the mouth of a wormhole, offering shortcuts across the fabric of spacetime. Though purely theoretical for now, it's a tantalizing possibility that continues to drive research and fuel science fiction. Another hypothesis is that black holes represent glitches in our universe's simulation, if one exists. Like cracks in a computer code, they could offer a glimpse beyond the boundaries of what we perceive as reality. If we were ever able to travel faster than light and survive the journey into a black hole, we might learn something entirely new about the nature of existence itself. On the other side of the debate, some scientists challenge the very existence of black holes. A theory proposed by Tokyo-based physicist Enrico Raldi suggests that what we call black holes may actually be holograms, not in the sense of glowing images, but as mathematical projections of information encoded on a two-dimensional surface. In this view, the strange properties we observe might not belong to physical objects, but to illusions shaped by the laws of quantum mechanics and gravity. This holographic principle is still controversial, but it's gaining traction as physicists attempt to reconcile Einstein's theory of general relativity with the strange rules of quantum physics. In this context, black holes might not be cosmic vacuum cleaners at all. They might be more like giant vaults of information, storing data in ways we are just beginning to understand. So what lies beyond the singularity? The truth is, we don't know, at least, not yet. It could be another universe, an alternate dimension, or simply an eternal prison of crushed matter. What is certain is that black holes are not just holes in space. They're the ultimate cosmic riddles, challenging our understanding of physics, reality, and the very structure of the universe. What do you think lies inside a black hole? Is it a gateway, a trap, a mirror of our own universe, or something else entirely? Let us know in the comments below. If you found this journey into the unknown fascinating, remember to hit the like button, subscribe to our channel, and share this video so more people can join us in exploring the mysteries of the cosmos. Until next time, keep looking up, because the universe always has more to reveal.